Hello, I'm going to show you how to use the R companion package's correlateC function to do correlation analysis. I'm assuming you have already downloaded RStudio, and have installed the RCPA3 package. If you haven't done those things already, you want to complete your setup before trying to use functions from the package. I'm also assuming you have a basic understanding of how to work in the R environment. If you don't know what functions and objects are, you should review those basic concepts before practicing the skills shown in this video. The correlateC function has one required argument, x, which is set equal to a list of numeric variables. You set x equal to one list that contains two or more variables. The correlateC function supports a standard set of optional arguments. With correlateC, you have options to weight observations, specify the dataset name, the number of digits to display after the decimal point, and whether you want results printed to an HTML file in your working directory. The function also has a unique optional argument named stats that I will show you how to use in this video. You can generate a scatter plot by setting correlateC's plot argument to true. If x is set to a list of more than two variables, plot equals true will generate a scatter plot matrix. If the scatter plot markers overlap too much, you can use the jitter argument to see them a little bit better. To learn how to use the correlateC function for correlation analysis, let's work through some examples. To use our correlateC function to do correlation analysis, you type the name of the function correlateC, and in parentheses I'll start with the one required argument is x. And as the notes tell you, x is a list of variables for correlation analysis. They need to be numeric and entered in the form of a list with the variables to be correlated listed. Let's start with just two variables. So x equals a list, and then inside the list are the variables do you want to execute correlation analysis on. So I'm going to pick a couple of interval level variables from the states data set, like states BA or more education level, and states I'm just kind of picking some at random to demonstrate, but we'll look at the number of car fatalities. So you can run this for the most basic results. Gives us a correlation analysis, a correlation coefficient of -0.7. Surprisingly strong. If we want to add to this some options that would go along with a correlation between two variables, might include the inferential statistics we could get by adding stats argument and setting stats equal to true. That will add on to the correlation analysis, the same correlation coefficients before, now with the standard error, t-value, and t-statistic and the p-value. We can also ask it to create a plot using the plot equals argument and set plot equal to true. Let's give this a run, and it should give us a scatter plot in the plot window, so we can visualize the relationship between education level measured, the percentage of college graduates, and car fatalities at the state level. To use correlateC to examine correlation of multiple variables, we use a very similar syntax as correlation between two variables, just expanding the list argument. So let me demonstrate. So we'll run the correlateC function, and we will set x equal to a list. You might notice we're using the argument x instead of dv and iv, because in correlation analysis there's not a causal relationship, so we don't really use a dependent variable and independent variable. They're just variables to apply correlation analysis to. So I'm going to pick some different variables from the states data set. Some you might expect a strong correlation between the voter turnout from election to election. So I have 3 elections in here. Got 2016 election, the 2018 election, and we'll look at the correlation to the 2020 election. So you can see the X is set equal to a list, and inside the list argument I have 3 variables listed. So let's start with that. So the output is given as this table showing the correlations between the variables. So to pick one, the state voter turnout in 2016 is correlated with itself at 1, which should be expected. Correlated with the turnout in 18 at 0.866, and correlated with turnout in 2020 at 0.915. So very strong positive correlations among all these variables. Now I was able to see the entire correlation table by simply stretching the console window space. You may find it helpful in this instance to use the data argument to specify the data set, which is states, and then the list doesn't need to identify the data set anymore, only the variables. This can be helpful. I'll show you why. I'll run this again. It just makes the table shorter, and more compact, a little bit more elegant. And it's going to help us too, because I want to show the same optional arguments I had shown with correlation between 2 variables, but then apply it to this multiple variable situation, where I'm going to request inferential statistics by setting stats equal to true, and also request a plot by setting plot equal to true. Look what it does with the plot. Got our correlation analysis, our inferential statistics for those correlation values, and then the plot, we get a scatter plot matrix, which is kind of neat. So it's showing visually the relationship between voter turnout and turnout in 18, turnout in 2020. You can do this kind of horizontally. It's kind of rotating the scatter plots, so the turnout between VEP on the y-axis and voter turnout 18 on the x-axis. Notice the difference here. Like this plot, you can see I'm with the cursor here, has VEP 16 on the horizontal axis and VEP 18 on the vertical axis, and then this one over here is sort of a mirror image with VEP 16 on the vertical axis and VEP 18 on the horizontal axis, and similar comments for the rest of the table. So correlateC, setting the list equal to a list of multiple variables, can give you the correlation matrix, and if you want, you can get inferential statistics and a scatter plot matrix as well.